Let's take a look at how to name certain organic compounds. This is often the most complicated part of a chemistry course. If you ever go to university, you take organic chemistry, you have to learn how to name a bazillion different things. We're going to start with the simplest three. Organic compounds are hydrocarbons. They are made primarily of hydrogen and carbon. They can have oxygen and nitrogen and other chemicals in it, but mostly hydrogen and carbon. Naming hydrogen and carbons involves looking at three aspects: the number of carbons linked in a continuous chain, the family, the presence of double, single, or triple bonds in the carbon chain, because they can be double, single, or triple bonded together, the functional groups, the presence of structures other than hydrogen attached to the main carbon chain. We're not going to look at this number 3. Right? That one's not, we're not going to deal with that. So the length of the carbon chain. There's a system for naming chains of carbon compounds. It consists of 2 steps. A prefix tells you how many carbons are in the chain. So how many carbons are linked together in a single chain. The suffix tells you information about that carbon chain. Okay, so we've got a different set of prefixes now. This is different than, a little bit different than the other number of prefixes we've used. So you might want to write this down. We've got 1 is meth. This right here is called methane. It has 1 carbon. That's it. Then hydrogens fill it out. Each carbon has 4 bonding spots. Right? A carbon has 4 electrons in its valence shell, so it needs 4 more electrons. Each one of those is a bonding spot. So this carbon has 4 bonding spots, so it can bond with 4 hydrogens. This is methane. Number 2 is eth. There's 2 carbons. Ethane. Number 3 is prop. Prop, 3 carbons in a chain. Then you fill it up with hydrogens. Number 4 is bute. Butane. If you ever bought a butane lighter to light things, it had this chemical in it. Number 5 is pent. Pentane, 5 carbons. 6 is hexane, 6 carbons in a row, then filled up with hydrogens so that everything has a fully bonded spot. 7 is hept. 8 is oct. So some of these ones down here are familiar, but up to 4 is different. 9 is non. 10 is dec. 11 is undec. 12 is dodec. 13 is tridec. 14 is tetradec. 15 is pentadec. 16 is hexadec. 20 is icos. 100 is hect. So you can have 100 carbons long. There are 3 main groups of hydrocarbons based on the type of bonds which joins the carbons. Alkanes. Starts with an A, the first letter of the alphabet. The carbon chain is joined exclusively by single bonds. An alkane is indicated by the name of the suffix ane: methane, butane, propane, decane, nonane. The general formula for an alkane is CnH2n plus 2. So butane has 4 carbons and 10 hydrogens. So it has 4 carbons, and then you do 2 times 4 is 8, plus 2 is 10 hydrogens. Okay, so now we're going to look at a couple of anes. So I got another sheet of paper so I can fit. So we have pentane. Pentane, we look at the pent, that means 5 carbons in a row. So we label 5 carbons in a row. 1, 2, 3, 4, 5 carbons. Ane means that these are all single bonded together. 1, 2, 3, 4 single bonds together. 4 bonding spots. Now carbon, what we need to do is we need to fill it up with hydrogen. This carbon has 1 bond to it. So it can have 3 more bonds coming off it. And we're just going to fill these up with hydrogens for now. This carbon has 2 bonds, but carbon can have 4 bonds. So we got to put 2 more on this guy. Hydrogen, hydrogen. This guy has 2 bonds already to it, so we need 2 more. Hydrogen, hydrogen. This guy has 2 bonds, so we can have hydrogens. And this guy needs 3. H, H, H. Right, so pentane has C5, and then H, we take our 5, we multiply by 2 to get 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we add 2 more to get 12, right? 12 is equal to 2 times 5 plus 2. That's pentane. All single bonds everywhere. All right, let's look at another one. Octane. You hear about that a lot in vehicles. Octane. The octane level in the fuel. The oct means there is 8 carbons in a row. So 1, 2, 3, 4, 5, 6, 7, 8 carbons. Well, let's do the chemical formula. Let's see if we can do the chemical formula before we even do the H's. C is 8. Then, to get the number of H's, we do 8 times 2 plus 2. Right? We do 8, 2 times 8 plus 2 is equal to 18 H's. Okay. Now, the ane means every carbon is single bonded together. So single bond, single bond, single bond, single bond, single bond, single bond, single bond. Now we fill it up with H's. This carbon has only 1 bond to it, and carbon has 4 bonding spots, so it can hold 3 H's. Now, we don't have to put the little H's at the end of these lines. If there's nothing there, we just assume that it's an H. So there's 1 H, 2 H, 3 H's. This carbon can have 2 H's coming off it. This carbon, 2 H's, 2 H's, 2 H's, 2 H's, 2 hydrogens, and 3 hydrogens coming off that. That is octane. There's no letters there, so we just assume that it's hydrogens. All right, so the first part tells us 8 carbons in a chain. The ane means they're all single bonded together. Okay, so those are the alkanes. All right, next is the alkenes. It's got an ene, the second one. A carbon chain contains at least 1 double bond. A double bond is where 2 sets of electrons are shared between atoms instead of just 1. So it could have many double bonds. An alkene is indicated in the name by the suffix ene. If the chain is more than 3 carbons long, it is possible to place the double bonds in different places to produce a slightly different compound. The chemical formula will be the same, but the chemical structure will be different. These compounds are called isomers. The general formula for alkene is CnH2n. Using butene as an example, N is 4, so 2 times N is 8, so it's C4H8. Note this formula does not distinguish between isomers. So, we're going to look at a few alkenes. First one. Okay, so ethene. Eth meaning 2, ene meaning a double bond somewhere in there. So we got 2 carbons. Now the ene means there's a double bond. How many places are there to put a double bond in this guy? There's only 1 place. We put a double bond here. Now this carbon is bonded to each other twice. So now we can fill in our hydrogens. Well, this carbon already has 2 bonding spots used up. So we can put 2 more hydrogens like this. Same thing here. And ethene is C2H4. Right? The number of hydrogens is double the number of carbons. Now I want you to compare this to ethane. ethane would look like this, CCHHHHHH. You see how ethane and ethene look different. Okay, but now what happens when we get butene? So we're going to look up butene. Butene. The but means 4 carbons. Carbon, 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 carbon. So that's 4 carbons. So we know this is going to be C4H8. There's going to be 8 H's. Well, not always, actually. Sometimes there'll be C4H8. Sometimes not. Anyways, the ene means we have a double bond somewhere. Well, where do we put the double bond? Do we put it here, here, or here? We need some more information, don't we? Do we put the double bond here, here, or here? Well, here and here are the same thing, because we could just flip this around. So the first place and the last place are basically the same. Here and here are different. How do we distinguish? Well, we are going to make 1 butene. 1 butene means the double bond goes here. Double bond there, single bond, single bond. So how would this look? Well then, this carbon already has 2, so we put 2 here. This carbon already has 3 bonds to it, so we can only handle 1. This guy has 2 bonds to it, so we can handle 2 hydrogens. This guy can handle 3 hydrogens. And 1 butene is C4H8. Now compare that with 2 butene. 2 butene. But means 4 carbons again. 1, 2, 3, 4 carbons. Now our double bond, E means double bond, ene means double bond, and it goes in the middle. There's our double bond, single bond, single bond. Now for hydrogens, this guy can have 3 hydrogens attached. This guy can only have 1 hydrogen attached. This guy can only have 1 hydrogen attached, and this guy can have 3. So now we have C4H8. Now what would 3-butene look like? 3-butene would just look like this guy, only flipped around. Right? That would be 3-butene. It's the same thing as 1-butene because they're symmetrical. But now, here's an interesting question. Can we have something totally weird? Can we have 1,2-butene? Yes, we can. So the but means 4 carbons chained up. 1, 2, 3, 4. The one and the ene means double bonds. This tells us the double bonding spots. So we have a double bond here and a double bond here and a single bond there. All right, so now this guy here has 2 bonds already, so it's got 2 hydrogens. This carbon can't hold any hydrogens. He's already got 4 bonds. This guy can hold 1, and this guy can hold 1, 2, 3. So butene actually is C4H6. It doesn't follow the rule because it has 2 double bonds in it. We could have 1,2,3-butene as well, where it's double bonded in each spot. 1,2,3-butene. Okay, so that's the ene. The number in front of it tells you where the double bonding will happen. All right. Let's look at the alkynes. YNE. It's the last one. The A is 1, the E is 2, the Y is 3. The carbon chain contains at least 1 triple bond. The alkyne is indicated by the suffix -ine. Just like alkenes, numbers are used to indicate the position of the triple bond or triple bonds. The numbering system works in the same way for alkynes as it did for alkenes. The general formula is CnH2n minus 2. So butane has 4, so you do 2 times 4 is 8 minus 2 is 6. So the chemical formula is C4H6. Again, like the alkenes, this is a general formula. It gives no information about which isomer is represented. All right, so let's look at some ines. We're going to look at pentyne. 5 carbons. 1, 2, 3, 4, 5 carbons. A triple bond somewhere. Well, where is that triple bond? Well, that triple bond is determined by a number in front, 2 pentyne. So single bond, triple bond, single bond, single bond. So now we fill it up with carbons, or hydrogens. This carbon has 1, so it's 1, 2, 3. This carbon has 4 already. This carbon has 4 already, so no hydrogens. This one can have 2 and 1, 2, 3. So 2 pentyne will be C5H8. 5 times 2 is 10. 10 minus 2 is 8. Okay, so we could have 3 pentyne. Now let's look at this one. Okay, so I'm assuming by now you're getting this, how this works. I don't have to show you 1 pentyne, and then I don't have to show you 3 pentyne. But I want to show you one weird example. Can we have 1, 2 pentyne? Ooh, I'm asking you that question. So you're assuming that the answer is going to be no. Because why would he be asking us, can we have it? Well, the question isn't can we have it. The question is why can't we have it? Let's start drawing it out a little bit. Pentyne. 1, 2, 3, 4, 5 carbons. Now, this tells us that we need to have a triple bond right here, then a triple bond right here, then 1 bond, then 1 bond. Okay. Have you discovered why this is impossible yet? How many bonding spots does carbon have? Carbon has 4 bonding spots. How many bonds does this carbon have attached to it? This carbon has 6 things attached to it. 6 bonds. So this is not possible because this has too many bonds on this one carbon. So 1, 2 pentyne is not possible. 1, 3 pentyne is possible, and 1, 4 pentyne is possible, but you can't have 2 triple bonds next to each other. You can have double bonds next to each other because that's 4 bonding spots, but you can't have 2 triple bonds next to each other. All right. Look at these aromatic hydrocarbons. We're not going to worry about these too much, other than here's the information, and it shows you something. These aren't going to show up on a test or a quiz this semester. Maybe in Chem 30 they will. Aromatic hydrocarbons are a special class of 6 carbon cyclics with alternating single and double bonds. The basic structure is called a benzene. So you see you have carbon, 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 carbon. Double bond, triple, single bond, double bond, single bond, double bond, single bond. That's called a benzene. And we could just fill it up with all hydrogens. If an alcohol group is attached to the benzene molecule, the new structure is known as a phenol. If a methyl group is attached to the benzene, the structure is known as a toluene. If 2 chlorines are attached to the molecule, it's called dichlorobenzene. And they can have 3 different arrangements. So see how the chlorines are next to each other in this one? So these are kind of hard to see. There they are. See how the chlorines are next to each other in this one? It's called orthodichlorobenzene. The second one, the chlorines are separated apart by 1. That's called metadichlorobenzene. And the third is the chlorines are apart from each other. It's called paradichlorobenzene. You don't need to know those. Other than it's nice to know that a benzene has 6 carbon cyclics in it. The benzene is a 6 carbon cyclic with alternating double and single bonds. But you won't need to know that in this semester. You will probably need to know some of that in Chemistry 30. Right, so remember, alkanes, only single bonds. Alkenes, at least 1 double bond. Alkynes, at least 1 triple bond. The prefix tells you how many carbons in a chain. The ending tells you whether it's an alkane, alkene, or alkyne. And a number in front will tell you where the double or triple bonds are. All right, so thank you for watching.